Good morning. Intermediate algebra. I'm looking at doing some practice review problems out of chapter 8 and 9, hopefully answering some questions as we go along. And I'm going to work through some of the review ones that I put up. So I put up that great big long practice for the final document. And note at the beginning of it saying here's certain problems you should look at that are relevant to the chapters that we're looking at now. So before you start worrying about older stuff, you should look at the most recent stuff and be ready for this test that's going on later today for some of you and tomorrow for the rest of you. Based on the time slots that you've signed up for, some of you still need to get your time slots in here pretty soon because that starts out this afternoon. So topics for this test include radicals. That's simplifying radicals that end up with a few different things. Changing from fraction exponent form to radical form or vice versa. How does that work? Equations with radicals, solving those, and then the stuff with the quadratic formula. So solving equations using the quadratic formula as well as factoring and other tools that come into that, but being able to use the quadratic formula and square root property and how those apply to equations with x squared terms in them. So I want to work through some of those things. That's the concentration on this test. And then we've still got a little time to prepare for the final. Final exam is scheduled for this class on the afternoon of next week, May 7th, which is next Thursday afternoon at 3 o'clock. We got a block that was set aside for the final exam for this class. That doesn't mean it's going to work for everybody. So if you don't have time available on the afternoon of that Thursday, let me know, because I have these other finals on the 6th and 7th. I can fit you in during other final exam slots. So let me know if the 7th starting at 3 o'clock doesn't work for you. Planning on 4-hour blocks for the final, where you want to turn it in about the end of the 4-hour block. So 3 to 7 p.m. on May 7th, next Thursday, May 7th. Is the 1:15 final, but like I said, alternate times are available. If you contact me and let me know, we can fit you into one of the others. May 6th and 7th should be all the final exams for classes that have finals. Graduation was scheduled to be pretty soon after that. Grades are due pretty soon after that. Actual graduation ceremony for people is going to be a little different this year, but finals are on the original schedule. So I'm hoping some people drop in with some questions so I can talk about what's most relevant, but I have a few things written down, and then we're going to do some equations and see how the quadratic formula fits in with other methods. I'm going to work through some of those from the review that I recommended doing before this test. So if you've tried some of that, you can compare what you did to what I did on those. Let me get situated for that and we'll get started. Okay, so 8 and 9 are the chapters in the book that dealt with all of the radical stuff. And then quadratics, and they become square root property and quadratic formula, which of course involve radicals. So these are things that might show up in some of these. And that's why we covered parts of the radical chapter. We didn't go into a ton of detail about it, but we want to be able to do the parts that have radicals from the quadratic formula. We're going to have to do square root of b squared minus 4ac for that formula, and whatever b squared minus 4ac turns into, we need to be able to simplify it down. That's the work that's left in solving those. So we might get things like this. Now the variables, we got to think about how to simplify these with variables in them also. Normally, from the quadratic formula, we just have actual numerical values there, and we want to write these things in simplest form. So I wrote down a few just to do simplify, which means simplest radical form for those, which means Is it a perfect square? Does it have a perfect square factor? Does it have radicals in the denominator? Those are things we got to think about with these. So when you see a fraction inside the radical, we want to think of the numerator and denominator separately. That's one property, is that we can take it apart like that. On each one, is it a perfect square? Well, for 5 and 3, they're not perfect squares. No. Is there a perfect square factor? Well, again, for 5 and 3, there's no perfect square factors. They're not divisible by 4 or 9 or any of those perfect square things. Does it have a radical in the denominator? Yeah, it does. That's the problem with this one, where it needs simplifying, is we don't like to have denominators that have weird stuff like radicals in them. So we have to multiply by something that'll get rid of that radical. If it's a simple radical like this, that's easy to do, because the square root of 3 times the square root of 3 is just 3. So that comes out, square root of 9 is just 3. That comes out good. And then on the top, I have square root of 5 times the square root of 3. We can put those together. We get a more complicated numerator, but that's the simplest radical form. So that's what we would want to do if we ended up with a fraction in it. If you end up with a negative in there, same kind of questions, but you know the I is going to show up here, because you know this is not a real number. That should jump out at you. Anytime you have square roots, you have to worry about them being negative in there, and this one is a negative inside there. That's going to end up with an I on it. But it's the same three questions. Is it a perfect square? Well, negative 18 is not. Is there a perfect square factor? Well, sort of. Yeah, negative 1 is kind of a perfect square, because that's where our I is going to come from. And also 18 can be split up into 9 times 2. There is a perfect square factor there. So these two things I can do the square root of. I'm thinking of it now as separate pieces. And the square root of negative 1 is I, and the square root of 9 is 3, and the square root of 2, well, it doesn't have any perfect square factors anymore. That's as much simplifying as I can do. It's traditional to write the stuff out in front, the stuff that's outside the radical in front of the radical, so that you know only the 2 is on the inside and you know what's inside and out. So that would be the nice way to write that. If there's variables involved, it's the same question, but perfect squares looks a little different down here. So I'm going to think of this as two separate pieces. First of all, the number part, same old thing with the number part. 27 is not a perfect square, but it does have a perfect square factor. Again, the 9 goes into there, so I'll split that up. X to the 5th is not a perfect square, because I can't do half of that denominator. It doesn't come out nice. 5 divided by 2. So I have to split that up also. X to the 5th, I can split into exponents that add up to 5. So I'm going to go 4 and 1 on that. And then this is a perfect square, because I can do half of the 4. So I split that up. I got 3. I got x squared. And I got a couple of pieces that don't simplify, or that don't have any perfect square factors. So they're left inside the radical, and I just organize things together. Again, the stuff out front that's outside, 3x squared, and the stuff that's inside is inside. You can put them back together as a single radical there. And that, I don't know if it looks to you as simpler than 27x to the 5th, but it is. We shrunk the radical. That's our goal on those things. If we can't get rid of the radical, is at least to shrink it down. These kind of things aren't really simplified, but we can write in radical form on these. If it says write in radical form and simplify, then we can do our simplifying also with the radical expression once we have it written that way. So x to the 4/3 looks fine as an exponent thing. But if you write it in radical form, you got to remember the 3 means that's the type of root that it is, a cube root. And the x to the 4th is inside there. Simplifying that would be a little different. If we're looking at cube roots, we don't need perfect squares, we need perfect cubes. So that could also be rewritten, because there is a perfect cube factor in there. I could separate the x4th into 3 and 1, because the perfect cube there works out nice. We didn't do a lot with the other radicals. They don't show up in the quadratic formula, so we don't concentrate on cube roots and other kinds of roots. But those are out there. You might see them later, depending on what you end up doing. Beyond this class. Right, so that I, or your question, that the I will show up anytime you have a negative inside of the radical. Stuff outside the radical doesn't really get involved in any of this. But if there's a negative number inside the radical, that means you are going to get an I. Negative number can always be written as -1 times something. So that's where the I comes from, right? We'll see that on those. So if you do some quadratics and you're using that quadratic formula that looks, well, I'm going to write it down so that it's here. This b squared minus 4ac thing, if you're using this on different equations, then you're plugging in different values for b and for a and for c, and stuff can come out different. These could easily be fractions, or this could end up negative because of the subtraction in there. So various things can happen in there some of the time. You might get I things, you might get fraction things. You need to be able to simplify that down. That's really what is left to do on the quadratic formula problems, because x equals these two values. You've already got x by itself. The work comes in getting it simplified nicely, just using the properties to write that big thing in as simple a form as possible. If it comes out to nice numbers, great. If not, we want to write it as simple as we can. So that's the work that's left to do on quadratic formula problems. Equations involving this is probably the next place to go. Solving equations that have radicals in them. And I was on the labs and stuff recently, a lot of these kind of equations. But let me start with something like this. Well, I'm going to try to make this one come out nice. So let me see here. A little dangerous to just write this stuff down, but I'm making up one that's going to come out fairly nice. Okay, so this is an equation involving a radical. If it just says solve, then you have an equation. And the thought process in general is, let me try to get rid of the most complicated thing and work my way down to solve for x, to get x by itself. I got a radical in there. That's the most complicated thing. So I want to get rid of that. Have to isolate it first. The only way to get rid of a radical is to, well, the way to get rid of a square root is to square both sides. I don't say the only way, but that's the way to get rid of a square root, is to square both sides. I need this to be a side. This term that has the radical in it needs to be isolated. So I don't want extra stuff floating around. I got to take care of that first. So I'm going to subtract 5 from both sides. That does have a like term over here. So that's now x minus 3 on that side, and the radical is isolated. As long as you remember that step, you're on the right track to this. Now, squaring both sides does not mean squaring the little terms here. It means both sides of the equation. Writing this out is that whole thing squared, which is nice. It gets rid of the radical. But it's this whole thing squared. That's not so nice when you have two terms like that. That's x minus 3. Squared, the parentheses, very important there. That means it's x minus 3 multiplied by itself. So you do have some complicated stuff over here. But we got rid of the radical. We have an x squared. It's 3x minus 3x and plus 9. That's what you get when you square that out. So I got rid of the radical. What's the most complicated thing now? Well, I got an x squared term. Sometimes with these things, you end up with an x squared term out of that. That means you've got a quadratic. We have a couple of techniques for that, but they start with getting everything to one side, getting the 0 on one side. So I'm going to subtract 3x from both sides, and I'm going to add 11 to both sides. I'll do that all at once. To get the 0 over here, I got x squared minus 9x plus 20. Now, choice of methods on this one, and I'm going to work a couple of different ones because, look, this just said solve up here. You can do anything I want. But I'm going to use a couple of different techniques because I want to remind you all of both processes here. If it factors, then I can solve this by zero factor property. And that's the easiest way to do this. If you look at that, numbers that multiply to 20 and add up to -9. Well, there are some. So we can do this by the zero factor property. I already have the equals 0. I can factor because -4 and -5 work. So x minus 4 and x minus 5 are your factors that you get out of that. And that's your factors. So the property says either x minus 4 is 0 or x minus 5 is 0. And solve it out from there is pretty quick. X is 4 or x is 5. Now, if I'm doing an equation like this where I squared both sides at some point, I should have this nagging question in the back of my mind that says I have to check answers, because whenever you square both sides, you can turn false things into true. Some of these might not actually work. So when I see 4 and I see 5, I don't know if they actually work. I got to check that and see individually. So if you come back to the original with the 4, you get 12 minus 11 is 1, plus 5 comes out to 6. And 4 plus 2 comes out to 6. Yeah, those are the same. So x equals 4 checks out okay. That worked. 5, check that separately. If I plug in a 5, I get 15 minus 11 is 4. That's 2 plus 5 is 7. 5 plus 2 is also 7. So that checks out also. That's kind of a different than the examples we had on the lab. Both of those actually work. That can happen. Nothing weird about that. Both of those ended up working in that. So they're both equations. They're both solutions to that equation. Great. I said I was going to try that by both methods. If I want to get some practice with this quadratic formula also. So if I didn't think about factoring at all, I still need that 0 form, because the quadratic formula, I have to identify the A, B, and C. And those come out from the terms in order once you've got it in the equals 0 form. So coming off from this same setup, arrange it this way and get your terms. A is 1 because that's 1x squared. B is -9 because that's -9x. And C is 20. So just get the numbers off from the x squared and the x in the constant term in that order. Drop those in. So you got to remember what this formula is. Let's say you got to remember stuff. Of course, with the way that we're doing testing now, you kind of don't have to remember anything, but you should remember this one. This formula is going to be one that you're expected to know as you go along here. And the more times you use it, the more you remember it. So I'm hoping you're getting some practice with this. But the B goes here and here. The A goes here and here. And the C goes here only. That's the where the numbers go in the formula. And then, like I said, it's all just simplifying from there. There's a little bit to the simplifying, though, so I don't want to make that sound too trivial. X equals, the opposite of -9 is +9. I got inside the square root, I got 81 minus 80. Do the multiplying first and be careful with your signs in there, but that's +81 minus 80 is just 1. So I do have a perfect square there. Square root of 1 is just 1. So I have 9 plus or minus 1 over 2. Well, I don't really need plus or minus. Well, I do need plus or minus. I can do them separately because I know how to do 9 plus 1 and I know how to do 9 minus 1. That's 10 over 2, which is 5. And that's 8 over 2, which is 4. So I did get both of those solutions for what x can equal. Those are the numbers. We already checked them because we did them by factor. So if you get to that point and you have a nice perfect square there, you can work this out as nice answers, rational answers. That means you could have done it by factoring, but you get the solutions either way. So that method works fine on those. All right, there's a couple of these from the review that I want to work through and think about the steps on there. So the final exam review document, I'm going to grab some exercises off from that. Notice at the top of that thing, I left that note saying here's certain ones to think about that are relevant for this test before we start looking at the whole grand scheme of things for the final. And number 18 is the first one there. I want to get to that. It's phrased as a function. We're going to have some of these questions on the final that are phrased as functions. Almost everything can be put in a function language. It says find all values of x so that f of x equals 1. So any kind of equation problem can be made into a function problem by saying this thing, when the output is 1, or f of x equals 1. In other words, that's what it comes out equal to over here is 1. So we're trying to solve when this thing is equal to 1. It's an equation problem. Okay, that's 1 1/4. That mixed number is a little weird, but that showed up there, so we can handle it. That's all that's going on with the function piece. There is you're given an output and not an input. Functions, sometimes you're given an input. It says find f of 3. We could plug in the 3 into it. That's one kind of function problem. But if instead it gives you what f of x is equal to, your input is still a variable, and the numbers over here, that means they're telling you the output, what it's equal to, and you got to solve for the input. You got to solve for x. So it turns into solving this equation. I'm not ready to use the quadratic formula yet because I don't have the 0 on the other side. We need the x squared x term and number term here, and 0 on the other side. So I still got to get at 0 first. 1 1/4 minus 1 is 1/4. So I got C happens to be a fractional value. That's a little different looking. And if you're thinking, hey, I could multiply all of these terms by 4 and get rid of the fraction, well, you're right. That would be kind of a smart way to do this. But you don't really need to for the quadratic formula. You do if you're going to think about factoring. We don't do factoring problems with fractions in there. You'd get rid of the fractions first. But I'm going to use the quadratic formula. I can leave it as a fractional thing and do quadratic formula. I just have a equals 1, b equals -7, and c equals 1/4. You do have to be careful. Quadratic formula stuff, you do have to be careful about the signs. If there's a negative term, that's part of your coefficient, or that's part of your a, b, or c value. B is -7, the other two are positive. We drop those into the formula here also for the two solutions of this. Squared minus 4, this. Drop the numbers in. Be careful with the long bar. This whole thing is divided by 2 here. This is A, B is -7, and C is 1/4. So that comes out. Well, let's see how it comes out. 2 times 1 is just 2. Opposite of -7 is +7. Inside here, I have to do 49 minus, it just ends up 1. 4 times 1/4 is 1. So 49 minus 1, 48. So then I ask myself my simplifying radical questions. I got the square root there. Is it a perfect square? No, 48 is not a perfect square. Is there a perfect square factor? There is. There's a couple of them. We could take a 4 out, but actually we can take a 16 out and do it all at once. 16 is the bigger perfect square factor. So I'm thinking of square root of 48 as the square root of 16 times the square root of 3, and I'm simplifying it down this way. Square root of 16 is just 4. I got this. Now, 4 is divisible by 2, but 7 isn't, and these are separate terms. I don't have a 2 as a common factor that I can take out here, so I really can't simplify the 2 out. It doesn't come out of every term. And I can't really add 7 and 4 radical 3. I mean, in decimal form I could, but in radical form, they're not like radicals. The 7 and the 4 radical 3 I can't really add or subtract there, so there's no more simplifying really that I can do on it. Now going back a little bit in the details on this thing, I just wrote this down without going through all the calculations on this, but what happens with all this? Negative 7 squared is negative 7 times negative 7, so that's 49. And the next operations that you do here is all this multiplying, the subtractions at the end. So that's 4 times 1 is 4 times a quarter. 4 over 4 is just 1, so I ended up with 49 minus 1. That's the order of operations going on inside there. So along the way, we're doing basic equation solving and order of operations and all that stuff quite a bit. So that's positive 48. And I end up with inside there. So the way this course kind of builds up, turning around to get ready for the final shouldn't be that big a deal because most of the stuff that we did early on in the course we're still doing. We're still doing equation solving. We're still evaluating expressions. We're still using order of operations. We have to think back to those systems that we did early on, the systems of equations that we really didn't get back to. So that chapter, I want to get some review on after this test for the final. Remember your elimination and substitution method stuff with those systems. There was definitely one other from this review document that I wanted to do. I can get to all of those, but there was one other that I know turns into an interesting problem. So, see, number 35. So it involves some different kinds of factoring. So here we go. This is number 35 from the review. It says to solve this thing by factoring, but it says simplify your answers. So the final exam questions were pretty good about writing out the instructions, kind of to point in the right direction here. What do you expect? So read that out. It says to solve the equation by factoring, simplify your answers. Now, we don't have a formula for what to do when there's fourth degree stuff in here, when there's other exponents like that. So the only method that we apply to this kind of thing is factoring. We solve by the zero factor property if there's some other weird exponent. So solving by factoring is using the zero factor property. I got my zero already. I'm going to do the factor property, and then we'll see where we go from there. So I'm trying to do factoring on this polynomial over here. There's no GCF. That's the first thing I would look at. I got x's, but not on all the terms. I don't have any numbers in common to everything, so I don't have any GCF. So this is a regular factoring problem. 3-term factoring deal. I got to think about my middle number there. I got x to the 4th. I got negative 72. 1 times negative 72 is negative 72. Is there numbers here that'll add up to 1? Okay, that's really a 1x squared. I need to add the positive 1 and multiply to negative 72. Multiplying to negative 72 means I got to have opposite signs. So I'm looking at a positive and a negative. Sure enough, positive 9 and negative 8 will work. That'll add up to 1. So this is a 9x and a minus 8x. A little good factoring review built into there. Now do your inside-out stuff from the box. Take out your common factors from the rows and columns. Now I messed this up already because I was a little too hasty on that. My middle term is 1x squared. These terms always match. The variables here always match the middle term. Those are the like terms that add up to 1x squared. So those are x squared terms. I should have had the exponent in there. Now inside out, pull out your rows and column GCFs here. So the common factor here is x squared. Common factor here, they're both negative, so I'll use the minus 8 there. Common factor here is x squared. 9 goes into both of these. That's a positive 9. That multiplies outright. So I got these factors, x squared minus 8 and x squared plus 9. I still have exponents in a factoring problem. I should stop and think, can I factor these things further? But they're two-term factoring. They're two-term things. And they don't fit my difference of squares or my sum of cubes or difference of cubes thing at all. They're squares, but the 8, and then the 8's not a perfect square. The 9 is a plus instead of a minus. It's a sum of squares. That doesn't factor any further. This is not a square at all. That doesn't factor any further. So I can't factor any more. So apply the property how. The zero factor property lets me split this up. It turns into these two things. So like these review questions that I put out, I didn't make them. They were Professor Nowicki put this together a long time ago, but they've got questions on here that review several topics. So that solving by factoring was our zero factor property. That's from an earlier chapter. But right now, this just became a chapter. Well, it became a square root property thing to solve these out from here. We got equations with x squared, no x term. And we could solve them by quadratic formula, but they don't have an x term, so it's easier to just solve them by the square root property. We can isolate the x squared and take the square root of both sides. So we're reviewing several topics along the way on that. All right. So I can't do the square root of both sides until I isolate the squared thing. I got to rewrite this as x squared equals 8 and x squared equals negative 9. Then I'm ready to do square root properties. So see what we end up with here. Remember your plus or minus. When you do the square root of both sides, we're going to get plus or minus square root of 8. That gets x by itself. And the same kind of thing here, x equals plus or minus the square root of negative 9. But right, it says to simplify your answers here. Don't forget this. We got x by itself. We got these various solutions to it. Ended up with 4 different ones, which happens with something to 4th degree. And x is plus or minus any of those things. But they should be in simplest form. They got radicals. They're not perfect squares. No, kind of. This separates out into perfect squares. So we got to do out our perfect square factors and see what we get. This is 4 times 2 because 4 is a perfect square. And this is negative 1 times, well, 9's a perfect square also. That's all going to come out nice. So this is plus or minus 2 radical 2. And this is plus or minus I times 3, or I would write it as 3I. I would write it that way. So there's really 4 answers there. 2 square root of 2, negative 2 square root of 2, 3I, and negative 3I. X could be any of those things, and they all should work in the original equation. We didn't square both sides at any point in this, so we shouldn't get any weird extraneous solutions. They should all work. not going to go through the process of plugging those in. That would be kind of rough on that. But they all work. Those are the solutions there. So that went through zero factor property and square root property, which is a nicer way to finish those off. You can apply the quadratic formula sometimes to other equations like this. So let me look at an alternate approach while I'm looking at this. Sometimes there's equations that don't start off with an x squared and x in a number term, but they can be rewritten that way with some clever rewriting of stuff. And I want to point that out. We can use the quadratic formula if we can rewrite the equation and make it into a nice quadratic thing with an x squared and an x term for a different variable like this. So I could have also done this. If you have exponents that fit this pattern where this is the square of this one, I can let this be, I can bring in another letter for this because it's not the same thing. It's a different thing. But I'm going to let that be u. So this will be my variable. And this is my variable squared, right? X squared is x to the fourth. So u squared is x to the fourth. And I can rewrite this thing, turn it into a quadratic. They call them equations quadratic in form because you can rewrite the thing and have a perfect square, squared term, a variable term, and a number term that's still equal to 0. So you can rewrite that thing as a quadratic. Now it's a quadratic equation that your formula would work for, but you're solving for u. The quadratic formula tells you u equals whatever. And if you solve this out by the quadratic formula, you'll get the 8 and the negative 9. But those are the values of u. So what you end up with, I'm going to skip past that quadratic formula part, but you end up with these things. And then you have to remember, wait, u is just the name that I put in there for x squared. So that just means we're back down to this. And you can finish it off with the square root property. So we get back to the same thing on it. You can sometimes manipulate an equation to make it into a quadratic so that this formula will work on it. And that's why a quadratic formula is useful in a lot of settings. Some techniques to that, including kind of a clever substitution for those. That's useful. Oh, 29 and 35. Let me see the other ones that I was pointing out as good ones to look at for this test. All right, just having some uglier numbers in there. We might actually use a calculator a little bit. So let me go through one of those that does that. I'll do number 38. Number 38 from the review. Quadratic. Sometimes we actually want to calculate some stuff and get just decimal form instead of all this radical form and whatnot. So 38, another function question. What your function s of t? It's I'm not going to write out the whole word problem, but it's talking about the height above the ground at time t. So it's another thing with the equation in terms of time. Gravity's working on it. This one's in so it's similar to the basketball thing I was talking about in my last video, with the downward pull of gravity on it. This one's in meters. S is in meters and t is in seconds. So t is the time. This is starting off at 8 and going up and back down under gravity right here. So the picture's in the review thing, but we're supposed to find the time at which the ball strikes the ground below. So strikes the ground is when all the height is gone, right? When we get to height 0. S of t equals 0. So again, they're giving you the output. The output is the height of this thing. And they want to know when the height gets to 0, when the output is equal to 0. So that's the value that goes over here, and you're trying to solve for t in it. It turns into solving this equation. So turning this into a function problem, you got input-output stuff. And when you're given the output, you have to solve for the input, or you can solve for the input on these things. Those are decimals already, and we want to know how many seconds it is. So I don't want some weird, radical expression. I want the actual decimal. That rounded is fine. We're going to have to do some calculator stuff on that. Same formula, but instead of trying to get simplest radical form, I'm just going to do out the calculations and do some rounding if it doesn't come out nice. That's the deal with that. So t equals, so I'm plugging things in the same way as before. I got my containers to put stuff into. In the quadratic formula. Long division bar that I got to do last. But now I'm just putting these in and doing the calculations out. A is negative 4.9. B is positive 5.5. And C is 8. So those go in these places. And the easy calculations I'm going to write down, but then I'm going to actually use calculator on some of this. 2 times this comes out negative. This is also negative. And then this is either plus or minus. So we'll see what we get inside here. That I'm going to use calculator for. All right, so calculations, being careful with my signs and whatnot. I was doing Tragon here before. Like this. I'm trying to calculate. It's inside the radical. I'm not doing the square root yet. I'm doing what's inside the square root, that discriminant piece. I don't want to do too many calculations at once, but I think I can do what's inside here all together. 5.5 squared minus 4 times negative 4.9 times positive 8. So that's going to square and multiply and subtract. I'm doing quite a few calculations at once. That's what you get inside of the radical. It's 187.05. I'm going to write that down. And then I'm going to think about the next round of calculations here. That's my discriminant part. That ended up positive, so I know I got real numbers now. That's good. Now, plus or minus is not one operation. That's 2 different things. So after I do the square root, I'm going to do the adding and subtracting part. But let me just take care of the square root and not try to do too many things at once. Square root of 187.05. What's wrong with that? Oh, I'm used to having parentheses on this, and I didn't open a parentheses. But the square root of 187.05 is 13 point. Here I'm going to do some rounding. 13.68. That's this piece. 13.68. So I got this. You do have to be really careful about order of operations when you finish this up. It's that whole thing divided by negative 9.8. So I got to work these out separately and do the division carefully. So negative 5.5 plus 13.68. Get that answer. That's the whole top divided by the negative 9.8. The whole thing divided by that comes out negative 0.835. And then I got to do the whole thing with the minus. Negative 5.5 minus 13.68. Get that answer. Divide that by negative 9.8. Now I got negative divided by negative. That one comes out positive. 1.957. That actually looks a little bit rational. But anyway, those are the t values. I'm off the screen. Okay, one of those makes sense and one of them doesn't. Okay, so let me stop the calculator thing and think back to what I'm talking about here. This is supposed to be the time when it hits the ground. We don't have times before he threw the thing. We're not going backwards in time. We're only looking at after he threw it. So we're looking at this many seconds is how long it takes to hit the ground. So we're talking about approximately 1.957 seconds is when the thing will hit the ground. That was one of the longer questions on a final review. I mean, it's one of the word problems, but there's not a whole lot of interpretation stuff to this kind of word problem. It's a function, and you're given the output to it. You got to read enough of it to understand you're given the output, and you're solving for the input. And it says round the answer to the nearest tenth. So I guess that would be 2.0 seconds to the nearest tenth if I want to round it a little differently. All right. All right, so if y'all are listening out there, if you haven't sent in your exam time slot yet, get that to me. I do have a handful of people down for time slots already. Where'd that list go? Yeah, I have several people down for time slots already, including Dan and Willie both. Several others, but several I haven't heard from. So if you haven't sent me the time slot, do that right away. I will get tests out to a few of you this afternoon and some more this evening and some more tomorrow morning. And then give me a little time after you send those in. I'll try to catch up on the grading, see how this affects averages. I can get back to you with your exam grade, but also how that affected your average, how your average turns out for all this. Homework and labs and everything will factor into that. So I'll let you know how your course average is between now and the final. I'll try to get those out to people before Monday. And then we have, I'll have one more announcement on Monday with recommended things for getting ready for the final again. I think I want to get answers down to these review questions, the other ones, so that you can check answers on those. But let me know if you have any other topics you want me to answer some questions on or work some examples on. I can do that between now and then. That EATS online homework that wrapped up on Monday, that was it for the homework. Now that was the last homework. So I'm totaling up points from that. So that's the last thing on the labs and homework. This review thing would be a lab, but it's not done for a grade. So there's no more lab grades on that. No. So I've gotten averages done up and communicated those to some people. If you want to know what your average is, I can do that now, but it's I'm going to do that after the test. So I'll get this fourth test in there. It's the 4 tests. Labs and homework each count as much as a test grade, and then the final counts for the twice as much as each test. So the final is 2/8 of the average. And I'll get the other 6/8 all put together after this test is done and get that out to people. Let me know if there's any other questions as we go along. And I will have the Friday session that I plan on being online Friday at the usual time. I think I got to pre-record that one because something's come up during the day, but I will have that video out on Friday, just working some more of the review questions and some examples that'll try to illustrate the stuff that we did earlier in the course, especially systems, because that's been a while since we've looked at things like that. So other topics that we haven't looked at in a while, I'll try to concentrate on Friday as we get ready for the comprehensive final. I'll talk to you all then.